Hello, Wharton students. Today we're going to go through 2014 AP Calculus BC for your response question number 1. So the first question asks to find the average rate of change AT over the interval 0 to 30. So the basic formula for average rate of change, we call it ARC. It could be the y values of B, y values of A over B minus A, right? So this represents the amount of gas clippings remaining in the bin measured in pounds, right? Measured in pounds, T in time and days. So we're asked to find the average rate of change A over the interval 0 to 30. So we can substitute this as 30 and 0 and 30. So given that AT is 6.687 times 830, we have to use the calculator. But if you calculate, if you put 30 in the rate here, that would give us about 0.7892 pounds. And A0, which of course makes this exponential part equal to 0, equal to 1, because anything to the 0th power is 1, right? So it will still be 6.687. Okay, so if you calculate 0.7829 minus 6.687 over 30, this gives us approximately minus 0.197 pounds per day, right? So since this is a ratio in percent, the negative sign also here indicates that the amount of grass clipping is decreasing at the average rate of 0.197 per day over the 30-day interval. So let's move to part D now. Find the value of A prime 15. So what is A prime of 15? Anything that has a prime in calculus means instantaneous rate of change at 15, right? So we can take a derivative of this function. AT is originally equal to 6.687 of this. If we take a derivative, the basic formula for the exponential function, this exponential part becomes to ln, the natural log. So this is 6.687 ln of the base 931 times the original function 0.93931 times t, right? So if you just simply put 15 in t, that would give us about negative 0.164 pounds per day. So at exactly a t equals 15, which is 15th day, the amount of glass clippings in the bin is decreasing at the rate of approximately 0.164 pounds. All right, and find the time t for which amount of grass clippings in the bin is equal to the average amount of gas clippings in the bin over the interval of 0 to 30. So we first have to find the average value of AT over 0 to 30. So when you say you're taking the average of the instantaneous rate, we are also taking a derivative, and we are integrating it and get the derivative by, you can use this formula for C. So this is B minus A over A to B of integral, right? So AT dt. So this is sort of works as the average value of AT over a certain interval. In our case, it will be 0 to 30, right? So we can just calculate straight from here. A average, I should say A average is equal to 1 over 30 from A to B. So it's going to be 0 to 30. 0 to 30, 687 points times T dt, which gives us, if you put in the calculator right, this would give us 1.907 pounds, right? So now let's solve for T at AT. So this is the AT that we found here. So this is AT. So now AT is equal to 6.687. And if you put a T, this has to equal 0.907, right? Because this is what AT should be. This, if you solve for T, this would be this equals 0.97 over 6.687, which gives, if you solve for t, you can put in this calculator and solve for the equation. This would give us ln. So we take a natural log of ln on both sides. So this would give us about 12.414 days. All right. Then that was C. And the last part, D, it asks us to use linear approximation to A at t equals 30. So what is the formula for linear approximation? Linear approximation gives us, so L of t is equal to A t plus A prime t. This is the instantaneous slope, right? So it serves as a slope of the linear equation, and t minus, so x minus t. Okay, so if you put it in our case, we already know that AT, so we have to get it for a L30, right? Because this is given as t equals 30. And we already know that the value of A30 and A prime 30 from A and B, right? So A30 was about 0.78 and A prime 30, we still have to get it, but simply putting in here, right? This formula. So if you calculate that again, we can get A prime of 30. So let's put it there. So A30 was originally equal to 0.7829 plus, if you put 30 in this formula and put it in the calculator, this would give us about minus 0.559, right? And then it will be t minus 30. 30 was the original t. And let's solve for this. Given that LT would be 0.5 pounds of grass, we can make it this whole equation equal to 0.5. This would give us, and then we could solve for t later. So like this, and then if you solve for t, you would get t equals approximately 35.05 days. Okay, so we can say that this predicts that after approximately 35 days, the amount of glass clipping will reduce to 0.5. Right. Hope this video was helpful, and I'll see you next time. Thank you.